Hello and welcome to my tutorial on gravitational potential energy. Today's learning objectives are: can you describe what is meant by gravitational potential energy? And can you calculate the change in energy in an object's gravitational potential energy store for a change in height? Now, for our starter activity today, I would like you to match each space object to its gravitational field strength. Now, whilst you're completing this starter activity, please press pause on the video to give yourself enough time to answer. Only press play when you're ready to go through your answers. Okay, so the answers are as follows. The Sun, which has the greatest mass out of all of those objects, has the greatest gravitational field strength of 293 newtons per kilogram. The Earth has a gravitational field strength of 9.8 newtons per kilogram. Now, some textbooks round that up to 10. The Moon has a gravitational field strength of 1.7 newtons per kilogram. Mars has a gravitational field strength of 3.7 newtons per kilogram, and Jupiter, which is the largest planet in our solar system, has the greatest gravitational field strength out of the three planets given there, Earth, Mars, and obviously Jupiter, of 24.7 newtons per kilogram. So what actually is gravitational potential energy? Well, gravitational potential energy is the energy stored in an object due to its position above the Earth's surface. So when you lift an object in a gravitational field, this requires work. And this causes a transfer of energy to the gravitational potential energy store of this raised object. The higher the object is lifted, the more energy is transferred to its gravitational potential energy store. And the amount of gravitational potential energy depends on the object's mass, the gravitational field strength, and the height of that object above the ground. If you are to increase any of these, if you were to increase mass, gravitational field strength, or height, you would increase the amount of energy in its gravitational potential energy store. So, how do you calculate gravitational potential energy? Well, this is the equation that you need to learn. This equation is not given to you in the exam, so you must make sure you learn it. Gravitational potential energy is mass times gravitational field strength times height. And sometimes it's easier to use a formula triangle. And the reason why we use formula triangles is to make the rearranging of that equation a bit easier in that exam. So gravitational potential energy is mass times gravitational field strength times height. Now, when you use a formula triangle, remember that that top line means divide, and that these bottom quantities are multiplied. So you can see these dividing lines mean multiply. So if you wanted to find gravitational potential energy, it would be very simple. You would cover up gravitational potential energy, and that would leave you with mass times gravitational field strength times height. But if you wanted to find, say, for instance, gravitational field strength, you would cover up gravitational field strength G here. And if you covered that up, you would see that you are left with gravitational potential energy divided by mass times height. So a formula triangle makes that rearranging a lot easier. And we're going to have some practice of these questions a little bit later in this tutorial. So gravitational potential energy. The quantity symbol is capital E with a subscript P, the unit is joules, and the unit symbol is a capital J. And for mass, the quantity symbol is a lowercase m, the unit is kilograms, and the unit symbol is kg. And then for gravitational field strength, the quantity symbol is a lowercase g, the unit is newtons per kilogram, and the unit symbol is newtons per kilogram, capital N / kg. And then the height, the quantity symbol would be a lowercase h, the unit would be meters, and the unit symbol would be lowercase m for meters. Now there are some common conversions that you might have to carry out for these calculations. Sometimes you're given the mass in grams and you have to convert it to kilograms. To do that, you would divide by 1,000. Sometimes you're given energy in kilojoules and you have to convert it to joules by multiplying by 1,000. Sometimes you get an answer in joules and you're asked to convert it to kilojoules. To convert joules back to kilojoules, you divide by 1,000. And finally, sometimes you're given the height in centimetres and you have to convert it to metres. How you would do that is you would divide by 100. So this is a worked example. A crane raises a 250 kilogram object a height of 20 meters. Calculate the energy gained in its gravitational potential store. Gravitational field strength is 9.8 newtons per kilogram. Now, whenever you're given a question, what you should do is you should dissect that question. Look what the question is asking for, highlight it. Look at the data the question has provided you with and highlight that too. So, a crane raises a 250 kilogram object a height of 20 meters. Calculate the energy gained in its gravitational potential energy store. So you can see you're being asked to calculate that gravitational potential energy. You've been given the mass of 250 kilograms. You've also been given the height of 20 meters, and you've been told that the gravitational field strength is 9.8 newtons per kilogram. So use that information to complete the formula triangle. Substitute these quantity symbols for the values being given, and you should get 250 kilograms multiplied by 9.8 newtons per kilogram multiplied by 20 meters would give you the gravitational potential energy store. And the answer for that particular question would be 49,000 joules. Or if you wanted to convert that to kilojoules, you would divide by 1,000, and that would be 49 kilojoules. Now, what I would like you to do is I would like you to attempt those 5 questions on your own. So to do that, you might want to rewind the video back to where you had the formula triangle and make a note of that equation and that formula triangle. And then whilst you're answering these questions, please press pause on the video so that you have enough time to answer them. When you've finished going through the questions, press play and we'll go through the answers together. Okay, I'm assuming that you've done the questions now. So, a rugby ball is kicked 15 meters into the air. It has a mass of 0.4 kilograms. What is its maximum gravitational potential energy? And the gravitational field strength here on Earth is 9.8 newtons per kilogram. Well, just as we did in the worked example, you're going to dissect that question and you're going to highlight the data that you've been provided with. So you've been given 15 meters as a height, 0.4 kilograms as a mass, and 9.8 newtons per kilogram as a gravitational field strength. Well, then you use that data to then substitute the data into the formula triangle. So gravitational potential energy is 0.4 kilograms times 9.8 newtons per kilogram multiplied by 15 meters. And that would give you gravitational potential energy store of 58.8 joules. Okay, question 2. This one's slightly harder because a conversion was required here. It says, what is the gravitational potential energy store of a 4,200 gram cat balancing on top of a 2.5 meter fence? Gravitational field strength on Earth is 9.8 newtons per kilogram. Well, again, you look at what the question's provided you with. 2.5 meters height, 4,200 grams for the mass, 9.8 newtons per kilogram for gravitational field strength. Now again, you're going to have to add this data to your formula triangle, but you need to do a conversion first. You can see that you've been given the mass in grams. To convert 4,200 grams to kilograms, you have to divide by 1,000. So 4,200 grams divided by 1,000 would be 4.2 kilograms. 9.8 for gravitational field strength and 2.5 meters for height. So if gravitational potential energy equals mass times gravitational field strength times height, then gravitational potential energy store would be 4.2 multiplied by 9.8 multiplied by 2.5, which would give you a gravitational potential energy store for that cat of 102.9 joules. Question 3. What is the mass of a boulder that is stationary at the top of a 520 meter hill with a gravitational potential energy store of 25,000 joules? Gravitational field strength is 9.8 newtons per kilogram. Give your answer to 1 decimal place. Now, what makes this question more difficult is that you have to actually rearrange the formula, because here they are looking for the mass. The second thing that makes this question slightly more difficult is that you have to provide your answer to 1 decimal place. So don't lose marks by forgetting to do that. So again, dissect your question. You've been given a height of 520 meters, a gravitational potential energy of 25,000 joules, and a gravitational field strength of 9.8 newtons per kilogram. Again, add that data to the formula triangle, and you'll have 25,000 joules equals, you can see the mass multiplied by 9.8 multiplied by 520, that's 520 meters. So how would you rearrange that equation? Well, you would cover up the mass, and if you cover up mass, that would leave you with 25,000 divided by 9.8 times 520. And that would give you a mass of 4.9 kilograms. So it's not a particularly big boulder. So the Mars Exploration Rover has landed on a 50-meter high hill on the planet Mars. It has a mass of 185 kilograms and a store of 34,225 joules of gravitational potential energy. What is the gravitational field strength on this planet? Now, this question is more difficult because you're having to find the gravitational field strength which again means that you have to rearrange your formula triangle. So your equation has to be rearranged. So again, you've been given 50 meters in height, you've been given a mass of 185 kilograms, and you've been given a gravitational potential energy store of 34,225 joules. So add that data to your formula triangle, and you can see that to work out the gravitational field strength, you would cover that up, which would give you the gravitational potential energy divided by the mass times the height, which would be 34,225 divided by 185 times 50, which gives you a gravitational field strength of 3.7 newtons per kilogram, which we know is a gravitational field strength on Mars because we learned that in our starter activity. Now the final question, question 5, this one again is more difficult because they're asking you to use the formula triangle and you're going to have to rearrange the equation to find the height. And the second thing that makes this question slightly more difficult is that you have to do a conversion. You've got 900 grams there. Remember, you have to use kilograms. So 900 grams is your mass, 13.23 joules is your gravitational potential energy. The height is what you're trying to find out, and the gravitational field strength is 9.8 newtons per kilogram. Again, add that information to your formula triangle. And again, you can see height is what we're trying to find out. So you will cover up height. You need to do your conversion, which is 900 grams to kilograms is 900 divided by 1,000, which is why your mass here was 0.9 kilograms. So please don't forget that you have to convert grams to kilograms, and you do that by dividing by 1,000. So you have your rearranged equation here. And that would mean that you would have 13.23 joules divided by 0.9 kilograms multiplied by 9.8 newtons per kilogram. And that would give you a height of 1.5 meters. So I hope you found this tutorial useful. I hope that after this tutorial, you're able to use the formula for gravitational potential energy to complete questions like the ones I've shown you in this tutorial. But please don't forget, you are not given this equation in the exam. So please go away and make sure you learn it. Thank you. Bye-bye.